Good morning, students. In this video I just wanted to point out some of the ways that you can create the more intricate or complicated circular feature drawings in the quick exam at the moment. So I'm going to go through this problem circular 7. I'll do the advanced level solution for it, and hopefully I'll just talk about some of the ways that we can go about defining the shapes, because you've got this kind of, with the circular object which has I guess plates or sections which are cut at varying thicknesses. So this part in the very front of the shape has a 4-unit thickness. This part over here has an 8-unit thickness. Because they're cut into the circular feature, there are some shortenings of length that occur. For instance, this length here is not a whole number. So I'm going to show you how you find the true length of that shape, and you'll see that it sort of comes back to what we've often mentioned, which is that in third angle you need to use all of the views that you have in order to define all of the parts of the shape. So to begin, if we have a long length here, 23, I can check the length of this front side and say, okay, this is going to be our front face. This is where we're viewing the object in this direction. So what do we see first? I suppose starting from the middle of the shape, we would see this 4-unit high end piece. We can know that 4-unit high part is going to be 7 units off of the bottom or top of the face. So I'm going to come up 7. I'm then going to come up 4 here. What do we have next? We're going to go across slightly. This is a distance of 3 units across. And then if this is if the next part we're joining onto after this straight section, this little straight section in here, if then we have the arc which goes all the way to the top of the shape, and we're dealing with something like that. So just right to the top of that boundary. Next up we have this thickness, which is 3 units, and then back down a distance of 5 units, because we want to get to this this flat surface in here. So down 5, and what I'm going to do is I'm just going to bring my line to the very midpoint of this front view. So this is a symmetrical shape, or it's doubly symmetrical, symmetrical left to right and top to bottom. So I'm going to first mirror this shape top to bottom, and then I'm going to mirror left to right. And so this is, if we were looking on this side edge here and seeing the shape, then we would see this profile. And you'll notice that in all of this region here, if I can I show that? Is it going to work with what I'm trying to do? All of this region here, there are no lines on that side. No lines blocking off that region, just as there are no lines showing up here. We do have some hidden lines, but we'll wait until we've located the circle here on the top part of the shape before putting those hidden lines in. The next view that I'm going to draw is this view off to the right, because there's information which is needed to draw the top view, which we can obtain from the right view. So we'll start with a circle which is centered in the middle of this draw box, and it just touches the outside edge. That's how these draw boxes are always set up, by the way, in this little script. They're always set up to be just the outer extents of the shape. So if your shape ever doesn't touch the outside edges, you've probably measured a line wrong somewhere. Okay, what do we have next? So I can drag this line across, and I want to start from this intersection here and the outside edge of the circle and go the whole way across. As I mentioned earlier, this length 17.5499, that's not a whole number. It's not something that we can say easily measure and then bring across to the other shape. I mean, that would work, but it's going to be difficult on our memory. Okay, so we have that so far for the outside part of the shape. If we were seeing through the shape to see this inner edge in there, then we would have some hidden lines. So this edge, if I drag that across, it can only start again on the edge of the circle, and we have another one down here. Both of these lines are hidden. We would not see them directly looking on that outer edge, but we would see them as hidden lines in a third angle view. Again, we would have last hidden lines for the hole, but I'll wait a little bit for that. Okay. Now, because the this object, as we can see in isometric, it has an edge here which runs the entire length of the shape, which is part of the outside part of the cylinder. So if that cylinder is touching the outside edge, then when we view the object from the top down, it's actually going to be seen as a rectangular object, and we would need to fill in some of the other detail that will tell us that a circularity is present there. But from the top down, the entire cylinder will appear rectangular like that. What sort of details are we going to see? Well, we're going to see the distance between this line, this edge and that edge is 18, but the length of this line here, which we would have to see from the top down, is 17.549. So I mentioned it's going to be a pain to locate this one. It would be a pain if we didn't have the third angle view down there to the right. So what I can do, if I run a line up from these edges, we've got these three third angle views in alignment, but quite specifically in this case I want to be able to use information on my bottom right view to translate across to my top view. So I'm going to need some means of translating that information across. Just the same way that if I have features on the front view, I can use the ray command and say, okay, yes, I've got a line here. For this corner, I have a line over there. I can check the features are in alignment, and I can check the features are in alignment in the top view as well. But I want to be able to take a line from here, and I want to check it against this direction on that view. So the way we do that is to run a line up and across so it touches the leftmost edge of the right view and the bottommost edge of the top view, and we run that line up at 45 degrees. Don't worry about the fact that it's coming over that shape, that won't be a problem. Now I can use my ray command. I want to locate this corner here because that corner is going to show up a feature in the top view. So I'll use the ray command to run a line straight up from that corner and another line straight up from this corner. Where these lines intersect our newly drawn diagonal line here, we have the ability to then translate that information across at right angles. Now we have some feature lines that we can locate on the top view. And I don't need these as construction lines, so I can get rid of my construction lines. I just wanted to get this information over here. Now I can start to play around with it. Okay, so on the outside part of the shape, say I'm working on the very leftmost part first. The very leftmost part, I have this little object here, three units long, and which is going to start out, if I run that across, 3 units long, and it's then going to span the entire length, or just slightly less than the entire length of the shape, 17.549, as opposed to the full length of 18. So this tiny little length of line in here, 0.225 units long, that is the offset that, say, if I take this line here and ran it up at 30 degrees, that is the offset that this long part of the shape has from the far edge, from the outside edge. So I can trim off the part of the shape that I'm interested in. I want just I don't need that, and I don't need this, and this second line I'm yet to play with. But basically what I'm going to have, once I've mirrored the shape completely, this long section, I'll just temporarily hide this piece so it's not confusing. This piece here, going from outer edge to outer edge, is the outer edge of the cylinder and the outer edge of the cylinder, and then the rectangular section inside that is the face in there. So that's what we've currently located, and it should be, oops, I haven't joined these together. It should be the same length, 17.5499, as we have in here, 17.5499. The middle rectangle, that can be located in a similar fashion, so we're going to come up from this point until we intersect there. Go to the middle part of the shape. I'm going to trim off this part, the middle part of the shape here as well. Trim off that. And now I can mirror a couple of times to get the shape in the right location. So from this outer edge, where I located that shape before, that is the distance that we have out of here, which is in alignment with, if we see in alignment with this corner to create that shape. So it's also the edge that we need for this center rectangle. So if I mirror this object like so, I can then mirror the object about its center. And again, doubly symmetrical, so there's a lot of shortcuts that we can take advantage of with the mirror command. And this is how this shape would appear from the top now. We've got that inner rectangle. Oops, microphone just jumped off its perch. That should be better. So we have this inner rectangle with the circular feature on it. We have the two outer flanges. The only thing that we're left to put on the shape is that inner circle and the hidden lines that it shows up, and we should be finished here. So I need to measure the width of this circle. Circles also, we should be measuring them on the 30-degree mark if they're drawn in isometric. So I can measure it this way. That's not the true radius of the circle, nor is this. But measuring at 30 degrees, I can say that this circle is 2 units in radius. So coming across and down, a circle of radius 2. So I then know that if I have a feature in here, it's going to be 2 across. That's a hidden line for that one. Double check that that width came out okay. All of these lengths should be whole units, 3.5 or half integers. That's okay. I can even save myself a bit of time and copy this, because the spacing on the whole is going to be the same. Copy that across. And last thing I need is the center lines on this shape. So every time there's a circular feature, we need to put a center line in. Select all of these lines, change their type to center, and there we go. And unless I've made some sort of embarrassing omission, I should find that is entirely complete and entirely correct. So that's how you go about drawing this shape in third angle. If you needed to draw the shape in isometric, you have actually, I won't do this exact shape. I'll do I'll do number 7. That's number 6. So if you need to draw another isometric shape, but in another circular shape, but now in isometric, you've got a slightly different focus or slightly different problem to take into account, and that's just how you're going to go about constructing all of these circles. You need to be a bit just a bit careful when you're laying that out. The first thing I'm going to need is to change my snap type to isometric, so I can actually start drawing isometric circles. And the circles that I want to draw are going to be drawn on this plane, so I can press F5 to rotate the cursor. First thing I'm going to do now is locate the center of one of these circles. So I know that again this circle is 11 units in radius. Then my bottom length here should be 22, and so should the height. It's going to just fit. The circle will fit neatly inside this this red box. So I come up 11 units, and this is the center point there for my ISO circle. So I'm just touching, my circle will just touch those outer edges in both cases. What I'm going to do is I'm going to copy this circle a few times, and then I'll start making some trims to it. So we'll have one of these circles right at the very front of the shape. We'll have one circle right at the very back of the shape, again just touching those outer edges. I might leave that one at the back because I'll copy it forward when I need it. And now it might be time I'll start putting on some of the features on the front of this shape. So I can see from the front view that this shape is only half of a circle, semicircular, or half of a cylinder in its entire front portion of the shape. So because I'm at the front part of the shape over here, I only need half of this circle. So I'll start by locating the center. I'll run a line across and I'll extend that line to the other side at the 30-degree mark. I can then trim away the part of the ellipse that I don't need, because we just need the half of the cylinder at that front end. What do we have next? So I can go, we then have an interface which is 6 units back, but this is also, I can see from the front view, it's another circular or cylindrical feature. It's 6 units back, and it's 18 units wide, so 9 units in radius. If I start another circle from this center point, I give it a radius 9. I have a third circular feature on this front edge, which is 7 units in radius. If I say measure it to there, also centered about the same point and circular on the front. Ellipse, ISO circle, from the center, 7 units. And in all of these cases, I don't need the top half, I just need the bottom half of the shape. Right, so if I take these features that I've just produced and I copy them back in the depth of this isometric view through 6 units, as I can see that they should be copied here, I will locate them in their present positions. What else do we have? So we have that from this front view, there's the outer rim of a circle, and there is an inner semicircle here, and then there's a kind of gap which has been cut out of the middle. You can see from these hidden lines as well, we have a hole down there, and the hole wraps itself around to come to the top view. In the top we can see again that there's a notch cut out here and a notch cut out there, and then there's a kind of wrapping around of the circle in between. So basically how this is going to show up, we have these selected objects are forming a solid, and these selected objects are also forming a solid, and then we have a gap in between. It'll help if I start to join up some of these lines. So coming back at 30 degrees through my 6 units, I can join up these lines, I can join up these lines. This one will be some 23 units, it won't go all the way back, so I won't put it on just yet. Neither will this one. I won't draw those lines just yet because we're going to not need their full length. Okay, there's a lot of line that I have going on here which is unneeded. For instance, anything which is on the left side of these two selected objects, it's obviously going to be hidden. Anything of these curving arcs in the background. So I'm going to just trim away that part and that part, get a bit of the confusion out of there. Another thing that we can notice is that when viewed in isometric, the frontal cylinder will have one of its edges, if I'm coming out on 120 degrees in this case, or negative 120 degrees, if I can intersect this point and draw a line which is tangent to that edge of the arc, heading back along the depth of the shape, the same direction that all of these other lines are showing our depth. If I can head it back along the depth of the shape, anything which is above this point is going to be sort of hidden by this this frontal part of the shape. So I can trim off anything up there, which is also between anything below this line. So I'll trim that and trim this, or actually just delete that because it's not connected to anything. I can join up these lines at the end of the shape, 2 units across and 2 units across. I can do the similar thing that I had done earlier, where I'm running down to this tangent point and then running a line across. that 25 units, that 25 unit length that I'm getting there should also be the length of the shape here, so that I'm finding that's correct. It says I've got all my lines and angles correct. So that's coming along reasonably well. I have at least the front detail on the shape. I'll then have a line coming back from this corner is going to run almost the whole length of the shape. It's going to run until the this rising up section at the back of the shape. This all this part here of the shape that rises high at the back. That's not going to it's not going to have a line down here, not a solid line anyway. So what we have here for a length is 21 units. I can draw from this corner back 21 units, and in fact it will be the same on both sides. I can go from this corner back 21 units. Start to put in some more detail on the shape. What else do we have? So knowing that there is a high standing circle, I can see in this view that we have a high standing circle which is right up the back part of the shape, extends up this 4 units width. I'm going to grab the full ellipse that I have here and copy it forward through 4 units. You see that just lines up with those points there. Now we won't actually need any of the bottom of this ellipse, because it's only the top feature that needs to be described. The bottom feature is going to be the detail is going to be described by this rear ellipse. So I'm going to trim off this unneeded bottom part, and I'm also, just for added clarity, I'm going to get rid of the unneeded part of the rear ellipse as well. So from either of these center circles, if I snap to the center and run up at 60 degrees, I'll eventually intersect the highest point of the ellipse and come across on a tangent. Getting that 4.00 says I've got all my angles right. And now that I've found that point, I can trim off all of the unneeded parts of the rear ellipse. I need this line and this line. Take that away. So now I'm just starting to, piece by piece, get all the bits of the ellipse in the right place. The ring at the back part of the shape, it has a thickness of 2 units. We already, oh no, we haven't described that yet, but I can come across, I can say here this is 2 units in, and here this is also 2 units in. I'm going to put another ellipse in this part here, another ISO circle, which has a radius of 9, so the outer one is 11, 2 units less than that gives us a radius of 9. Once again, I don't need the bottom part of that ellipse, I can just trim that off. And what else can we say? We would then need to have the rear edge of the shape, this edge along here, also needs to be visible, or in this case will be visible through that thin ring at the back part of the shape. One way I could define it is by coming to this corner here, and in my depth I know that the thickness of this outer ridge is 4 to the back of the shape, so I come from this point, I come back 4 units, that was at 30 degrees, right? Yeah. And then showing this length part or width part of the shape, just until it runs from that corner back until it runs behind the archway. That shows the rear end of the shape. I would see up here, I would see a little part of the inside of the arc, so I might copy this ellipse from its base point just to touch that back corner, and then trim off every part of the ellipse which extends beyond the back of the shape, just like that. So now I'm just seeing what's in front. So we've got almost everything in this shape now. We've got the rear archway, we have this front notch which has been taken out, and the last thing that we have is this little, it's not elliptical, it's a sort of keyway which has been cut into the shape. So we'll first get its position, say from the front of the shape, very front of the shape to the front part of the circle is 9 units. And very rear part of the shape to the rear part of the circle is 7 units. The circle's radius is 2, and it is on the very center of the shape. So from here we come across 9 units, I think it was. That's right. Yep. Then if the radius of the circle was 2, we can come back that way 2. I can now I need to rotate my cursor until I'm drawing circles on this plane. See, my cursor is aligned with those faces. Drawing an ellipse, which is an iso ellipse, with a radius of 2. The distance between the center of these circles is 5 units, so I might copy this one through a distance of 5 units there. Can get rid of my construction lines. Now I need to take away every part of this shape except the parts which are describing this kind of outer edge. So I'm going to use trim on these lines and take that away. So it's not just a line which is drawn on top. This object has some depth. If I check my front view, I can see the depth of the shape is 2 units. So I can copy that through a distance of 2 units, and then again trim away everything which is unneeded. Trim and or delete. So if all of my lengths and actions and descriptions of things, all of my trims were accurate, when I hit QE, this should show that I've made no mistakes. So that was a fully worked example of this particular problem. So also I want to point out here that the expert problem, yes, I'm somewhat practiced with this, but it's 10 minutes is not an unreasonable time. I mean, I was taking my time and explaining to the viewers what was happening. I would expect that a student who's practiced would be able to complete this in 20 to 30 minutes, something like that. I think would be a reasonable expectation. So hopefully I've explained a few of the trickier solutions in this kind of problem when you need to work with both circles and isometric, or circles and third angle. So we have the test coming up in the next couple of weeks. Make sure that you get lots of practice in for that, and if you do have any difficulties or problems that you can't get around, come and see me. I hope this video has been helpful and will enable you to get a lot of practice in at home. If there are any comments or questions, just leave them in the YouTube page. Okay, thanks for watching.